Hello friends, this video on Electrochemistry part 26 is brought to you by examfear.com. No more fear from exam. Now let's understand a very critical topic called electrolytic cell, right? And electrolysis. So in electrolytic cell, we do just reverse of what we do in galvanic cell. So here the chemical reaction is done using electricity. So a normal, generally a non-spontaneous reaction which won't occur if we just keep the compound in the beaker on its own. Those kind of non-spontaneous reaction is made to occur by using electricity. Here external source of voltage is applied to bring about a chemical reaction. It's a very, very important process. It is used for electroplating. We'll talk about that. It is used for purification. Electroplating. It is used for purification of metal. It is also used for electrowriting, I think, or electroscripting. There are so many things it is used for. We'll explain that. And if you see the word electrolysis, electro means again my electron or electricity, and lysis means to break. That means we're using electricity to break the chemical, right? So the non-spontaneous reaction which won't happen on its own. For example, water. You take water, right? Water will not break into hydrogen and oxygen on its own. It won't. But if you pass electricity, if you do electrolysis of water, that is called hydrolysis, then you can actually break water into hydrogen and oxygen. This is a non-spontaneous reaction. Correct? It won't happen on its own, but by passing electricity, it can happen. Right? So in the process of electrolysis, what is happening is the electrical energy of this battery or whatever power you're adding to, that is changed into chemical energy. Electrical energy is changed into chemical energy. You must have noted in galvanic cell, we are doing just reverse. We have this chemical energy and we convert that to electrical energy. Right? So thermodynamically non-spontaneous reactions for which delta G is greater than 0, for example this reaction, that is made possible by passing electricity. Right? The mechanism is pretty easy. This electrolytes which you have, they'll have cation and they'll anion. Right? Anion is the positive charge, cation is the negative charge. There will be electrolyte here. We'll use electrolyte here. Here also we'll use electrolyte. There will be some electrolyte. We'll have cations and anions. And this electrolyte will be either in molten state or will be in aqueous state. Aqueous state means you will have water molecule with that. Molten is the pure form, just it is in molten state, right? And in this molten state or in this state actually, either molten state or aqueous state, these ions are free to move. Correct? They are free to move because they are in liquid form. They are either in aqueous state or they are in molten form. Now if you apply a potential difference here, right? So now if you see the anode, this part is anode again by convention, this part is cathode by convention, right? So we add anode to a positive part of the battery and this cathode to a negative part. Also we see the positive and negative is represented like this. So which one is negative, which one is positive, a little confusing. So the good thing to remember is the long one, right? If you break into small 2 half and then you just flip it, you get a plus sign, right? This long one, you just break this part and flip this 180 degree and put it like this. For example, you have this symbol. Correct? Now what I'm trying to say is you just break this part because it's a long one and then you break this part, flip it and put it here. So it will become plus. That means this is a plus side of battery. Correct? Just a tip to remember, the long one you can break it and then you can just make a crisscross, you'll get a plus sign. That means the long one is a plus sign. Anyway, so the anode is connected to a positive terminal of the battery, the cathode is connected to a negative terminal of the battery. Now again, since this is a negative terminal and this is a positive terminal, so negative terminal will have a lot of electrons. So the electrons will be transferred from this cathode or the negative terminal. So a lot of electrons will flow from here. A lot of electrons will come here. right? Since there will be a lot of electrons here, what will happen is, since this is now electrolyte, it will have cations and anions. Now, since there are electrons, the anions are the one which will have positive charge, will be attracted toward this electron. For example, if I have, let's suppose, copper sulfate solution, then I have Cu2 plus and SO2 minus in this sulfate solution, right? So this is my anion. So this anion will be attracted towards my cathode, because cathode is negatively charged, right? So the electrons are transferred from cathode using battery, and these electrons are taken by the, so thus if you see, Cu2 plus is taking 2 electron at cathode and becoming copper, and if you see, there is a reduction happening from 2 oxidation number to 0 oxidation number, right? So there is a reduction that happens at cathode. Similarly, at anode, there is a deficit of electron. So maybe there is a pure copper, let's suppose we have attached here. So pure copper will give electron and become Cu2 plus. So here if you see, oxidation happen. So oxidation is happening at anode and reduction is happening at cathode. And that is the formula we have shown, right? Told that NOx, red cat, reduction cathode, anode oxidation, right? The memory tip I gave you, NOx and red cat, anode oxidation, reduction cathode. So that is all about electrolysis. So where we use electric current to perform a non-spontaneous reaction. Okay, so we'll see how the copper purification is done using electrolysis. So let's see the purification. Now in purification, what we do is we take this electrolyte, and that is copper sulfate solution, right? This is my pure copper, a very small stick, and I took a bigger one, and this is my impure copper. Now what happens is, this impure copper also has copper ions. When you start the electric current, what happens is, you see, the pure copper will move. I mean, this impure copper, let's suppose, has 80% purity, right? So that means 80% are pure coppers. So the copper will get electrons. The electrons will flow in this direction. There will be deficit of electrons, right? And that deficit of electron will be fulfilled by the metallic copper, because this is impure copper, it has some copper. So that copper will become Cu2 plus ion. And what will happen is, if you see, the pure copper will go from here to here, but if you see, the impurity will settle down. And gradually, if you see, the impure copper side, that is my anode, will become less, and the cathode side, where we will be getting the pure copper, will become bigger. So if you see now here, all the impurity is settled down here, and the copper has moved, right? So if you see the reaction, what happened was, if you see the reaction at anode, so you see the reaction at this side at anode, I had this copper from this impure copper that became Cu2 plus, and it gave 2 electrons. And this Cu2 plus actually is the red one which you are seeing here. And this Cu2 plus is part of the solution now, right? This is my copper sulfate solution. It will have a lot of Cu2 plus and SO2 minus ion. Now at this at this cathode side, if you see, there are a lot of electrons. There are plenty of electrons here, because this battery is providing a lot of electrons. Now at this side, Cu2 plus will take these 2 electrons, will take the 2 electron and will become copper. Correct? So we had this impure copper here, it became pure copper. So other metals like sodium, magnesium, aluminum, they can also be purified, and they are actually purified on large scale using this method. Why? Because there is not suitable chemical reducing agent for these, because they themselves are a good reducing agent. They are not very good reducing agent for these kind of metals. So we use this electrolysis method to purify these kind of metals, right? So I hope you got the logic. I had this impure copper here. From this impure copper, there is a deficit of electron in this side. So this impure copper gave 2 electrons, became copper sulfate, copper plus, and copper plus is nothing but part of this whole ion, right? Because this solution will have nothing but copper plus ion and SO4 2 minus ions, because it's the electrolyte, copper sulfate electrolyte. This is my electrolyte, correct? And thus now in this side, since there is a negative charge coming in from this side, so there is a huge electrons here. So these electrons attract this copper plus ions and they become copper. Right. The next example is electroplating. Electroplating, what we do is, there is a metal, for example this is iron, and I want to cover this with gold or maybe copper, right? So we use electroplating for that, because you must have seen a lot of jewelries which are not gold but they look like gold because they have a plating of gold. So this kind of thing is done by, again, electrolysis method, and this electroplating also helps in rust prevention, corrosion prevention. We'll see that, rust prevention. And the way it is done is in similar fashion. If you see here again, let's suppose I have a copper ion. I'm trying to electroplate copper with iron. This is iron and this is copper. Battery started. The electron comes in this direction. There are lots of electrons here, and there's a deficit of electron there, right? It's a deficit of electron. Since there's a deficit of electron, the copper, this is my again anode and this is my cathode, right? So since there is a deficit of electron, what will happen is this copper will do what? It will become Cu2 plus and it will give 2 electrons, correct? Because there is a deficit of electron in this side. Now this solution is my copper sulfate solution, let's suppose in this case. So copper sulfate solution, that means we'll have a lot of C2 plus ions and SO4 2 minus ions, plenty of these. Now since at this anode we are getting more copper plus ions because of deficit of electrons here, so we'll have more copper plus ions, and this side will have electrons here, right? So this side will attract the copper. So if you see now, the copper is getting transferred from left to right. This copper is getting reduced and the same copper is being now used on it is getting deposited on the cathode side, from anode to cathode. And after some time, if you see, the whole iron plate is electroplated with copper. If you see now, the iron plate is not seen. I mean, this is iron actually, but iron plate has got a plating of copper. And this process is called electroplating. One more critical place where we use electrolysis is electrotyping. So in this case, different old monuments, right, which need a lot of human time to build, actually is replicated using electrotyping, right? For example, there's a big monument, very old monument, and maybe that needs, let's suppose, 10 years for one person to complete it, because it may have small minute details of work. So instead of spending time, we use electrotyping to replicate those kind of monuments. For example, let's assume that this is a very old monument and this has a lot of designs in it, small designs which you can't see, right? And we want to create exactly replica of this. So first thing is done is we create a plaster Paris, plaster Paris dough. We put this in this, and then once it is dried, we remove this particle or remove this precious object. So we got a dye kind of thing, or we can call it a mold, plaster of Paris mold. This plaster of Paris mold is dried now. We put a zinc layer on this, right? And then we create this kind of setup. Here we have now, if you see, the zinc actually, and the structure is already there, right? Now we start a battery. Again, we have more electrons here and we have deficit of electron here. Same thing will happen. The copper will lose its electron, right? And it will become Cu2 plus, and this Cu2 plus will go to this solution, is again my CuSO4 solution. And now if you see, gradually the whole thing will be filled. If you see these gaps, right, this all hollow space will now be filled with copper. So now what we'll get a new, exactly, if you remove this part now, you'll get exactly this thing. Correct? You understand what we are doing? We first made a dye of this using plaster of Paris, then we put a zinc. Since there was a zinc here and there was a copper here earlier, and again we have this same copper sulfate solution, Apply the battery, deficit of electron at anode. Copper becomes copper 2 plus, gives 2 electrons. And there is more and more electrons here, right? And what happens? Cu2 plus gets this 2 electron and become copper here and gets deposited here. So once we get this, we remove the plaster of Paris and we can get this polymer back. Correct? Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.